Okay, we are going to go ahead and get started. This is going to be an interesting day because work today has been real interesting, so I'm not as prepped as I should be, but hopefully we'll get through this. I will get the slides out later and we will go through any code we need to talk about. So this is scheduled to be our second of the two special topics lectures. Today is on graphics in Python. I'm going to talk about graphics in general for a little while, and then I'm going to talk about Project 3, and I'm going to give you some examples. Obviously, I cannot give you answers, but I'm going to give you examples that should hopefully explain a little bit more about how to do Project 3 and what I'm expecting. So, the first thing is an administrative announcement. I am pushing back the due date of Project 3. It was going to be due this Friday, the 4th at midnight. It will now be due next Monday, the 7th at midnight. Okay. So we will have Monday's lecture to talk about it if you have any questions or to go over any fine points of graphics or how the tools work. So it will be due Monday the 7th. I would recommend if you've got it done, go ahead and submit it by the 4th, just so you can worry about your other classes, but you will have until next Monday to get it done now. I need to talk to the admins to make sure the submission is still working and open. But I'm going to go ahead and grant schedule relief because there's a lot of people with questions about the graphics parts of the project that I haven't gotten to yet. Okay. And as a reminder, I looked it up. If I am reading the UMBC schedule correctly, the final exam for this class, since we are not having a combined final for all of 201, is going to be online on that following Monday. So Monday the 14th of December from 3:30 to 5:30, it'll be online on Blackboard. That is the scheduled time for the final if I am reading the UMBC schedule properly. If you are going to have any problems, if you have conflicts, work, or whatever, and that's a problem with you, you need to let me know as soon as possible. Otherwise, it'll be online that following Monday, so you'll have a full week, almost 2 weeks from today before the final. I will get a sample final out in the next day or so. As I said, today was just an interesting day at work, so I'm a little bit behind. We will get going. And I actually promise you I am not paying attention to the Ravens game. I have no clue how it's going, and nobody tell me. I don't care right now. So, those administrative notes. For those who are just joining the meeting now, the due date for Project 3 is delayed, and the final is the 14th. So, graphics. ggplot stands for Grammar of Graphics. GG is Grammar of Graphics. The idea started in the R programming language. R is a language that's commonly used in big data analytics. It's designed to handle massive, and by massive I mean trillions, quadrillions, etc. of transactions of data, and do statistical analysis on them. One of the drivers behind R is a guy named Hadley Wickham, and Hadley came up with the idea for ggplot, and it was a really cool library. And ggplot was the reason that a lot of data analytics people use R instead of using Python. And so Python said, well, let's just basically do a port. Let's do our version of ggplot and bring it into Python. And so they have done it. There are actually 2 or 3 different versions of the plotting software for the graphing software for Python. The best version, in my opinion, is Plot9. And that's why we're talking about Plot9 is because, as I said, in my opinion, it is the best implementation of the ggplot library. And it gives you a good way of creating some interesting graphics for a lot of, in some cases, pretty complicated data sets. We're in Project 3 going with the fairly simple ones. Okay. So we're going to talk about this in general first, and then I'm going to move to talking about Project 3. Okay, so a grammar of graphics. What the heck is that? What does that mean? Okay. Well, what you do for any graphic, for any drawing you want to do, for any illustration, bar chart, pie chart, line chart, scatter plot, whatever, you have to start by defining a basic object. And so you'll see, if you've been working on the project, you've already seen, you will see today, that you have to start with a basic plot object. Now, in Plot9, because of the history of where it comes from, the basic plot object is called ggplot. Okay? ggplot parentheses is how you start. You have to define that plot object first. Okay? Now, then you add what's called an aesthetic, a look. An aesthetic means how something looks, its appearance. And so Plot9 and ggplot in R use AES, which is short for aesthetic, to define the look of your plot. Okay? And so typically, at a bare minimum, your aesthetic will identify labels for the X and Y axes. In the simplest plots, we're just doing things on an X and Y axis, bar charts, column charts, multi-lines, lines, what have you. And so the aesthetic defines what labels, and by implication, what variables you're going to use for X and Y. And then if you have complex data, you don't really want to go black and white. You can define colors in the aesthetic to use for the different points, lines, and bars, and you come up with some interesting graphics that are presentable and that make the point you want to make. So you have your basic plot object, ggplot. That is a requirement. You have to start with that. Then you define an aesthetic, as much detail as you want, typically minimum X and Y, then also colors, groupings, what have you. Then you add a geometry. A geometry tells Python, tells Plot9, what kind of chart, what kind of graphic you want. Okay. You can do scatter plots. If you want a scatter plot, that is called a point geometry. That just says plot all these points on my graph so I can look and see what they look like and look and see if intuitively I can figure out something. If there's an outlier, if there's a point that's way off by itself, if everything seems to cluster, whatever. Scatter plots are useful things to do analysis. You can do bar charts, simple bar charts, histograms. You know, we've done things like that in this class. We created simple ASCII histograms. Now with Python, with Plot9, you could do more complicated bar charts. You could do stacked bar charts. Stacked bar charts are variations where you have different things on the same bar to indicate, for example, there were this many votes in Maryland, this many votes in Virginia, and this many votes in Pennsylvania. And you could put them all on a single bar. Histograms, columns, things like that. Now that you've defined the basic object, the plot, you've defined the aesthetic, and you've defined the geometry, then you can transform the data using any statistical methods you want, and a lot of them are supported, and then you can actually draw your chart. So let's look at some examples. Now, where I get these from, these simple examples, there's a tutorial. It's not great, but it's decent. This is the Plot9 basic manual, plot9.readthedocs.io. And then /n means it's the English version, and /stable means it's not one of the new beta versions. It's one of it's the current stable version. So what I want to do is walk through some of the examples that they give in this site and talk about what's going on and what they mean. Okay, so let's go back to this one. Here, plot 9, if you play around with it, comes with some data for you to learn, for you to practice with. Empty cars. Okay, empty cars is a bunch of data about cars that were manufactured at a particular point in time, I think about the 70s. And for each car, it talks about the make, the model, the weight, whether it was four-wheel, rear wheel, or front-wheel drive, how many miles per gallon it got, how many cylinders it had, 4, 6, or 8, or what have you. Now, in this case, you can see, I know we imported plot 9 in the beginning, but it is safer in Jupyter Notebook to additionally import anything you need in a specific drawing. So what we're going to do, and when I talk about project 3, I'm going to do the same thing. I'm just going to put an extra line here that says from plot 9 import my ggplot object. In this case, I'm going to want a point geometry. I want aesthetics, and then I want a couple of statistical analyses that we're not going to use, but I do want to explain that they're available, called line smoothing and facet wrapping, which is just ways of presenting data. Okay, so in this case, they take the data that comes with plot 9. Empty cars, as I said, is the car database that comes when you install plot 9. You have that. Don't worry about it unless you really want to play around with these things. This is just an illustration. So now we're going to create this graph right here on the screen. How did we create this graph on the screen? This is a single plot. This is a single graph. And it starts by saying we need a ggplot, right? We need a basic object. The syntax is ggplot parentheses. Now, what data frame, what data am I creating my graph from? And so here I'm going to say from empty cars. Now, when I talk about project 3, it's going to be from, the data we've created on election results. But what this first parameter inside the parentheses, first argument inside the parentheses is, this is the data that's going to be used to draw the plot. Now, I'm going to have an aesthetic. Okay. Again, I want to tell Python plot 9 what I want it to draw. The aesthetic says the first variable in the aesthetic is going to be my x-axis. Now, I could say x equals weight, WT. I could say y equals mpg. If you find it clearer to say x equals and y equals, that's fine. But by default, this is how an aesthetic is interpreted. The first item is the label and the variable to use for the x-axis. The second item in this list, the second argument, is the one to use for the y-axis. And so you can see down here, we've got weight on the x and miles per gallon on the y. Now, I want to define this by color. I want to use different colors to use different things. And so I'm going to use the gear, which is how many speeds it is, 3 speeds, 4 speeds, 5 speeds, 3 gears, 4 gears, 5 gears. Okay. And calling it a factor is not a huge thing. That just is how you would represent it. You could actually, instead of saying factor gear, you could just say gear. That's fine. And it still produced essentially the same plot. Okay, so aesthetic from MT cars, motor cars data. I'm going to have weight on the x-axis. I'm going to have MPG on the y-axis, and I'm going to differentiate using the gear shift. I'm going to show 3 versus 4 versus 5 speeds. Plus geom point. So this first thing in here, and look where the parentheses balance, right? This is the parentheses for gear. The second right parentheses balances this one with aesthetic, and this one balances the parentheses at the beginning of motor cars, MT cars. So this parentheses is still open. But remember what I said. First, I said create the basic object. The basic object is a ggplot from this data looking like this. Now, What do I want? Do I want a bar chart, a line chart, something else? This geom point is the way of saying I want a scatter plot. I just want you to plot the points on a graph. Okay? I just want you to plot the points on a graph. Stat smooth method equals ln says I want you to smooth out the data by making a linear transformation. Okay, we're not going to get into linear regression. It's essentially do a linear, but if you've taken statistics, if you haven't taken statistics, don't worry about it. If you have taken statistics, what this says is do a linear regression on the data, and that's how you get these lines that are in there, right? And facet wrap is a way of telling Python, I don't want all of this on a single graph because that would be ugly. It would be hard to read. And I'm actually going to show you some really ugly graphs. Facet wrap on gear is a way of saying, I want you to create a separate little plot for each value of gear. 3 speeds, this plot red. 4 speeds, this plot green. 5 speeds, this plot, I guess that's purple. I don't think it's blue. I think it's supposed to be purple. Okay. And so this is an example where I've taken data which says I've got these cars that are 3 speeds, 4 speeds, 5 speeds, and they weigh this much, and this is how many miles per gallon they get. Okay. And so each little point, each red point is a specific car. It's a specific value for the database. This is a specific car that weighed a little over 3,000 pounds and got about 22 miles per gallon, and it was here. Whereas this was a 3-speed car that weighed just under 4,000 pounds, and it got a little under 20 miles per gallon. And when I do the linear regression, I can see that for 3-speed cars, the heavier they are, the less miles per gallon they get, and here are the actual values. And then I can look by comparison to 4-speed cars. 4-speed cars tend to get better miles per gallon for weight, but they also tend to be a lot lighter than 3 speeds. 3 speeds are probably more like pickup trucks or big heavy SUVs, whereas 4-speed cars tend to be a little sportier. And so they're a little bit lighter and they get better gas mileage. And again, here are all the 4-speed cars. Here is a specific value in the database. And we plot as a point that specific value on the database, and then we get a linear regression, and it looks like this. And so the same for 5 speeds. And so this 3 different graphs is created by this facet wrap command, which tells plot9 I want to do 3 separate things, rather than trying to jam all 3 of these into the same picture. So this is an example of using plot9 to take a data set, create a scatter plot, do a linear regression, and show me the relationship between weight of the car and miles per gallon the car gets for each of several different gears, 3 speeds, 4 speeds, 5 speeds. Okay, so that is actually a fairly simple graphic to create. Okay, but you can do that from plot9. That's an example on that website I pointed to, which is, by the way, the link in the, there's a link to this specific website in the Project 3 assignment. Okay, the next thing, and this is all done in a Jupyter notebook. I've just copied and pasted from a Jupyter notebook using plot9 and doing all these things. The next thing is a part of the data. I just printed out some of the data. This is all from the website. I printed out some of the data, and it says, oh, I have an Audi A4 with a 1.8 liter engine built in 1999 with 4 cylinders. It's an automatic transmission, model 15. It's front wheel drive. It gets 18 miles in the city, 29 in the highway. And it's officially it's a passenger car, and it's officially a compact. Okay, this is the data that exists. This is just an example. This is 5 lines of Audi data that you get from head, right? And if you look at this class where these are compacts, I said, okay, now create a bar chart that shows how many different cars there are in each class. Okay, again, start with a ggplot. There has to be a ggplot object from the miles per gallon table. Make it a bar chart, G on bar. Aesthetic, X equals class. Because I did not give a Y, it defaults to a count. How many values are there on the y-axis? If I wanted some other value from this table, I would have said that on the y-axis, and I can create bar charts. The point of this is just to show you that this package can be used to create scatter plots and linear regression, like on the previous example. And here's an example of a bar chart that would give you some data. Now, here's a little bit more bar chart with a little bit more data on it that you can see. Again, it's the same thing from the MPG table, the miles per gallon table. I just want to know how many are there in each class, but now I've broken it down further. The previous chart, okay, the previous chart just said how many were there total of midsize and how many minivan and how many pickup trucks. This chart provides me more information. It says how many rear-wheel drive, how many front-wheel drive, and how many four-wheel drive. So in this particular database, if you look at a pickup truck, it said the only pickup trucks we care about are four-wheel drive. All of our pickup trucks are four-wheel drive vehicles. Okay. Subcompacts, most of them are front-wheel drive. There's a couple of four wheels and some rear wheels. SUVs are either rear wheel or four-wheel drive. There are no front-wheel drive SUVs, and so on. Okay. Whereas midsize, your standard family car is almost all front-wheel drive because that's easier and cheaper to build, and those are mostly driven on the road because they're family car. Okay, this is just another example of a bar chart. The way I got the different colors is by this command, fill equals drive. Now, these values in here are the single quote, and we're going to talk about this with respect to Project 3. These are the names of the columns. So these are the names of the columns in the data set that we're putting in here, and we'll talk about this and give some examples and try to work through this. Okay. If you don't like vertical bar charts, you can do this horizontally. This is a bar chart where I say coordinate flip. The effect of coordinate flip is to turn the graph on its side. Instead of being vertical bars, they'll be horizontal bars. Some people like these instead with their histograms, with their charts. This is essentially the same data. Theme Classic just tells it what color scheme to use by default. Okay. And again, now all of a sudden, class is not on X, it's Y, and count is not on Y, it's X, and that's what coordinate flip does. You can play around with this. Okay. For those of you who are really into this, I am such a geek. A few years ago, everybody thought this was cool, but now the time has passed, and nobody thinks Game of Thrones is cool anymore. It's all outdated geek stuff, but nonetheless. If you wanted to draw a map of Westeros, the main country/continent in Game of Thrones, using Plot9 with appropriate data will in fact let you draw a complete and entire map of Westeros. And you can see up here that you have the north, which is kind of a variation of Scotland, which is inhabited by the wildlings. If you didn't know, Game of Thrones was essentially the story of England during the Wars of the Roses, obviously with fantasy thrown in, dragons and things like that. Dragons and White Walkers and whites and the like. But the wildlings were all the Scots. They were north of the Wall, which is based on Hadrian's Wall, essentially the boundary between England and Scotland. The north, which is the Starks. The Starks are the Yorks from the War of the Roses. The Lannisters are the Lancasters from the War of the Roses. The Tyrells are the Woodvilles, and you can go on from there. But you can draw each of their holdings, and on the left is the actual code that draws it. And if you had the data set, which you can get, by the way, from the website you could download the data and run this code, and you can actually draw in Python using Plot9 the complete labeled map of Westeros to show everybody that the Starks were here, the Aarons were here in the Vale, the Riverlands, the Tullys had the Midlands, which are the Riverlands, the Westerlands, the Lannisters, the Lancasters were over here, the Iron Islands, which is a variation of Ireland, is off here, and so on. You can draw this entire chart. Everything here is just drawn using Plot9, using the code shown on the left of the screen. In this case, it's geometry map, geom_map. They are very happy. Plot9 has a lot of stuff built in to do all kinds of maps. That you're going to say it's going to be called Westeros. ggplot object, it's going to be a map of Westeros. It's going to have islands. It's going to be a political map showing who claims it. It's going to have a wall, which is lines. It's going to have lakes, rivers, roads, cities. The political map is going to talk about, it's going to, for each family, it's going to take the centroid, it's going to take where they are and extend their land from there. And so on. The bottom line in all that is just that you can use Plot9 to draw something like this. It's that powerful, so we want to introduce it to you as a tool. For the chemists and chemical engineers, I hope this link is still there earlier today. If you go to this website, you have data and code that goes with it. And this tells you in detail how to draw the periodic table using this data chart. There's enough data as well. It has all the elements of the periodic table. But given this chart, this 2D list of elements of the periodic table, and this Plot9 code, here are the steps involved in drawing the entire periodic table. And this is what you wind up with, okay? Here you have the periodic table with the inert gases, the rare earths, the man-made elements, etc., all of them through there. And again, the bottom line in all this is the fact that you can use this one Python package and your one simple data file, and you can produce the periodic table yourself. You don't have to have any special software. That's one of the reasons we use Plot9. It's kind of cool because it's that powerful that you can do all of this stuff with just a little bit of code. Okay, and I believe that was the last slide I wanted to talk about today. Let's make sure to and let's make sure I've covered everything. And now I want to help you, or hopefully not confuse you too much, of project using ggplot. So here we go. I'm mostly going to be focusing on steps 11, 12, and 13 in the Project 3 assignment. Okay. I'm going to go over to Jupyter Notebooks, which I've got opened. I'm running Anaconda Navigator in the background. I fired up Jupyter Notebooks from Anaconda Navigator. I'm going to create a new notebook, and it's going to be Python 3. Okay. Now, some of the stuff I did last time, I'm just going to repeat. So make sure it works. I'm going to import pandas as PD, and I'm going to import Plot9. Now remember, test as you go. Test as you go. In Jupyter Notebooks, it's real easy. You just click run every now and then and make sure what you got works. Okay, so it looks like I've got pandas imported, and it looks like I've got Plot9 imported, and it's all there. Now, why do I say import pandas as PD? I don't know, laziness, tradition, the way I learned it. Instead of typing pandas as the module name and then the routines within pandas, I'm going to type PD which is 2 keystrokes instead of 6, which saves me 4 keystrokes every time. Am I really that lazy? Yeah, sometimes. It's okay. Okay, it just seems to be the tradition. If you don't import pandas as PD, nothing bad will happen, except I told you to in the instructions that you should, so you should, but that's why. It's kind of a tradition. Now, I don't know that I remember the exact path name, so I will look at the previous Jupyter notebook. If I don't, this is going to be called December 2nd, Project 3 notebook, so I'll know what I'm dealing with. Now I want to do a read. So data frame equals pandas, but remember, pandas was imported as PD. PD.read CSV, the data file on my laptop. Now remember, I am typing in the path name of this data file on my laptop. When you do your Jupyter notebook, you will type in the path name of the file on your laptop. Okay, so whatever directory you put it in, wherever you have it, that's what you type here. And we had to do the encoding equals ISO 8859-1. And I'm going to real quick check to make sure that I've got the right path. This is the version last time. Fall 2020 project. Yep, I did leave out one directory from this. Again, this is just the directory structure on my laptop. Okay, so when you're doing this on your laptop, wherever directory you put it in there, when we grade your project next week, we will grade it by replacing this line with the file that we have on our grading machine. You don't have to worry about that. You won't even see that. For your purposes to develop the program, you put in the file directory path of where you have it in your file. Let's run that, make sure it worked, and it didn't. Where did I get the problem? Users is plural is where I got the problem. Okay, and that solved the problem. Okay, again, if you mistype the path, not a big deal. Test, 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 test. I would hate to write 100 lines, 200 lines of Python, and then test and find out that nothing worked because I mistyped, I misspelled the directory name, because I'll guarantee you it would take me forever to find that error. In this case, it was real easy to find the error. Now, I just want to check to make sure that the data's in there correctly. So in pandas provides the head command, which by default prints out the first 5 and last 5 lines of the data when you run it. And I can see that indeed I have what looks to be the beginning of the file, and everything's fine. Okay. If I wanted more or less, I can do that as well. Okay. If I want to check the whole file is there, I just type the data frame name, I run that. That tells me, beginning and the end. 3,421 rows, 18 columns. Okay, now, stay with me here. I'm going to skip the part about sorting because we've done a lot of work on sorting, quick sort and selection sort. If you have questions about that, we'll get to them later. I want to work on graphics. So I'm going to skip the part of the program assignment where we talk about sorting. I want to go straight to graphics. Okay. Now, I'm being a hard case. Pandas gives you lots of really easy commands to transform data frames. And ggplot works really well with data frames. And so it would be really easy to use pandas commands to do these, but I won't let you use them because I want you to prove to me that you can program in Python. So stay with me. Here's what you're going to have to do. I will at the end, if we have time, and if you're interested, I'll show you the pandas commands that make it so easy, but those are forbidden for now. You have to do it the hard way, so I know you learn how to program in Python. Okay. I don't need to see the data frame anymore. I am going to convert this into a two-dimensional list. I showed you this last time. I'm going to call my two-dimensional list data frame, or DF, and that's going to be data frame dot values dot to list. And let me make sure I've got the syntax of that command right. Yep, just need the parentheses. Okay, let's run that. Now, if I want to see what DF is, I can see I have a two-dimensional list. Okay. I can see that I have a two-dimensional list. If I just want to see what the first value is, df sub 0, that is a one-dimensional list whose full values are here. Okay. So I read in using pandas because data frames give me nice things to do. They didn't make me deal with the header row. They automatically read the header row and did the right thing with it. I told you on Monday in the CSV lecture how you would do that yourself. Pandas did it automatically. So I let you do that. But now you've converted it to a 2D list. And right now, what we have is we have a standard two-dimensional list that is called DF. But it has all these fields we don't want. Don't need, just going to mess up our data. So we have to write code that will go through, and this is step 9 or 10, or 9 and 10 in the project. We have to be able to go through and pick out the rows that we want and the columns that we want. Now, I told you earlier that the only columns we want are year, which is column 0. Now, we're actually going to use what the data file calls state underscore PO, the post office code for the state. We're going to call it state. That's column 2. Candidate, the name of the candidates in column 10. Party, Republican or Democrat, or in a couple of cases, independent. That's column 11, and I'm going to double check myself to make sure I get this right. Okay, yep. And votes, which is column 14. The reason I have those constants is because those are the columns I care about. Now, I have to go through my 2D list, and I have to pick out the columns I want and the rows I want. In this case, in this example, I'm going to pick out the columns I want first. So to make it easier, I'm going to define a list. Columns I want equals, it's the list that consists of year, state, candidate, party, and votes. Those are the columns I want. Now, what I'm going to do is I'm going to create a new data frame. This is where my data is going to. That's going to be a two-dimensional list, but of course, we create a new two-dimensional list this way, like it's a new empty list. Okay, so it's a new empty list. Now, what do? I want to copy from the old list to the new one, row by row, but only with these columns, only with the columns that I care about. So I showed you how to do this last time a little bit, but basically it's this. I'm going to have to create a new temporary variable to build the lists, and I'm going to go through the entire data frame for I in range length of data frame for every row. I create a new temporary row. This is just going to hold one row at a time. And now for J in columns I, that's under lowercase up above, I have to be consistent. Temp dot append df sub I sub j. Okay, what this does is it goes out and gets the value from year, it gets the value from state, gets the value from candidate, it gets the value from party, and gets the value from votes. And it puts them into a new list, a new one-dimensional list. Now, when this list is complete, it's my new row, right? So now to add it to my new data frame, I just append temp. Okay. Now let's run that. Let's test as we go. And let's look at what new DF looks like to make sure I haven't made a mistake. Okay. Now you can see I have a whole bunch of rows, and I threw most of those columns away. I threw the state full name away. I threw the general election for U.S. Senate away. I threw not a special election away, et cetera, et cetera. What this has done is it's thrown away the columns I didn't care about, and it's just given me the columns I do care about. But now I have to throw away the rows that I don't care about. I told you I care about the rows that are Republicans, that are Democrats, and that are Bernie Sanders and Angus King, who are both independents, because those are the only people who win. Now, this actually turns out to be a minor lie. There's one more exception. There was one more other winner, but we're going to let her go. That was Lisa Murkowski. Recently, she's a Republican senator from Alaska, but she actually ran as an independent one year. She was defeated in the Republican primary. She got mad. She ran as a write-in candidate as an independent, and she was elected anyway as an independent. But we're going to ignore her. Your independents are Sanders and King. So now what I'm going to do is take this 2D list, which has all of these people, and we have to throw out everything except the rows that I care about. Now, the rows that I care about are Republican, in party, Democrat in party, or the name fields. I'm not going to show you all the code, but it's going to work something like this. We're going to do almost exactly what I want here. What I did here, we're going to build a new row and append it to a new list if this is a row we want. Now, I could take the approach, it would be valid to go through new data frame, new DF, and simply delete a row. In other words, what I could do is I could go through here and do something like this. For I in range length of new DF, if new DF sub I sub party not equal to Republican and new DF sub I sub party not equal to Democrat. And new DF sub I sub candidate not equal to Bernie Sanders and new DF sub I sub candidate not equal to Angus S. King Jr. Okay. Let me make sure I've got everything balanced here. Colon. Okay. Now what I do is I simply delete the row. Okay. And you know how to remove a list element. In other words, delete new DF sub I. You could do that. You could build a new 2D list just like I did here, element by element, or you could simply go through the existing one you've got and delete rows that you don't need. Okay, so let's try to do this. And that's going to be del new DF sub I. And I'm going to have to check my syntax. I haven't done that in a while. But what the heck? Syntax errors are me. Yep. Okay, something doesn't match. That's why the error's an error in in line 2. Check my parentheses, check my quotes. Yeah, what did it think the error was? List index out of range. Okay. For I in range, length of new DF. Okay. Double check my syntax there.
Professor.
Yeah.
Maybe try just Angus King, not Angus, like his full name. I just tried.
Okay, I'll have to look at the I'll have to look at exactly how it is in the file.
When I wrote it, how you wrote it, it took one element out of the list.
Okay. Interesting. Okay. Let's see, where was I? So say it's got to be in the thing. Let's see. Let's check. Hang on.
Is it when you delete a row, there's the list length gets smaller. So when you're at Does that have anything to do with it since lists are mutable?
That's possible. Lists are mutable. Yeah, that's actually probably what happened is that, yeah, it changed the length when I deleted it. So, okay, let's go back to, let's scratch this idea of simply deleting it and let's just build it. Let's start with another data frame is a 2D list. These ands become ors. And that's an OR, not PR. Okay. And the not equals become equals. Get my logic right, my Boolean. Okay. And I think it's the full name. I think it's S period in the database. We'll check it a minute. Okay, so now another df dot append df sub I. That first guess invalid syntax. I've got something. New df. Did I spell candidate right? Oh, guess what? The indices are wrong. That's my problem. Year is still 0, state is 2, candidates 10, parties 11, and votes are 14. Candidates 10. And yet this index, this new file only has 0, 1, 2, 3, and 4. Right? That's exactly the problem with it, is I needed to redefine the constants to make this work. That's what happened was it saw candidate as 10 and it says, or party is 11, and it says row I column 11, and it says, what are you talking about column 11? There's only 0, 1, 2, 3, or 4. Okay, that was why that didn't work. So what I needed to do is I'm just going to define party, redefine my constants. I'm going to define party as 0, 1, 2, 3, and I'm going to define candidate as 2. And now let's see if that one runs. Okay. All right. Let's see. What did I do here? It didn't like new DFI party. Okay. Hang on. All right. It didn't like that one. So for now,
So for
I'll leave those two out.
sorry to cut you off. So
No
what I
problem.
did was just follow the same format as the first couple that we did. I don't know if we're doing the exact same thing, but if we're
Yeah.
just doing like the Republican, Democrat, or Bernie Sanders or Angus King,
Right.
I did the same line that you did, but then underneath I did the temp again, the temp list,
Right.
and
Yeah.
then the columns, and then just appended to the to the list that we have, the data frame that we made.
Yeah. Okay. That's probably the easiest thing to do. That's what I get for taking a shortcut. I'll fix the Angus King thing later. Not a dictionary, a list. sub I sub j. And now append the whole thing. Let's see what'll happen now. Still doesn't like it. Okay. All right. I'm going to move on because we need to get to the actual ggplot. But basically what we're doing here is we're just going through, and I'll fix my syntax to get this one. So yeah. New DF is indeed a 2D list. So whatever. Anyway, here is the key point that we need to have here. ggplot, plot9 works best with data frames, not 2D lists. I was helping a couple of you last night. You can make it work with 2D lists, but it's a pain in the neck. The advantage to a data frame is that it has the column headings built in for variable names, for these commands, and everything. So what we do, and for simplicity right now, since I've got new DF right here as a 2D list, I'm going to convert that to a data frame, and the syntax for doing that is right here. Okay, I'm going to copy that over. I'll change the variable name. I called it final DF. That's the data frame I'm working with. PD.dataframe. This would be new DF. Okay. New DF, columns equal year, state, candidate, party, votes. What this does is this converts my 2D list to a data frame for use with ggplot. Okay, so you are allowed to use this statement to convert to a data frame, something like this, when you have your, going through the Republican and Democrat and throwing out all the independents. I'll have to figure out. It's something I'm positive there's something really trivial I'm doing syntactically to cause this problem. Cell above. Okay. Okay. Oh, for crying out loud. Here's my problem. To do a comparison, I use equal, equal, not equal. That's an assignment. Okay. Still doesn't like it.
Professor, I think you have to do you have to create the first couple of items as a list itself, and then reference that in the for. So like the party and candidate,
right?
Put that into its own list, and then for J in that list, in that new list that we just made.
Okay.
That's what worked for me.
Okay. Okay, I'm not, like I said, I'm going to skip on to it because I will go back, presuming we have time. What time is it? It's 5 o'clock. I want to get on to some examples. Okay. So when I have my final DF, okay, now if you look at it, you've converted it back to a data frame, and it's going to look like something like, where's my example? It's going to look something like this, where the column heads are defined. It's not in, it's that one that went down here. Okay. The column heads are defined. When you say, here are the columns I want, this is what you're going to get. Okay. And this is one where I did it where it actually worked, and I have to figure out why. But I got just Republicans and Democrats. And so, for example, for part 12, I got just Maryland, Pennsylvania, and Virginia. Now, where is the here's the graphic where I was fooling around. Simplest case, I wanted to create that total votes for Republicans. This is section 11, and this is what's showing up on the screen right now. Is an example. This is a simple one. You shouldn't be satisfied with this. I'll show you a more complicated one. So in other words, I went through the data, and not only did I select just Democrats, Republicans, Bernie Sanders, and Angus King. For section 11, I just selected Republicans. So I now have a data frame that has just Republicans. So I made sure I imported, ggplot, geomcall, and aesthetic. Okay. What happens is if you're running a Jupyter notebook, if you import something back in cell 0 and later on you're running cell 31, you may not have these things available. So if you're trying to run plot9, if you're trying to run these ggplots and it tells you, oh, I don't know what ggplot is, I don't know what geomcall is, I don't know what AES is, whatever. The way you do it is you just put another import statement there from plot9. I want ggplot, I want geomcall, I want AES, because not everything in Jupyter Notebook is going to be run at the same time. You may not have run the import statement lately, so this is just the safest way to do it. If you get that error message, insert this import statement, and that'll get rid of the I don't know what this is mode. Okay. Now, here's how we actually did this. I did examples in the slides. I create a ggplot object. In this case, I use something called data frame. Data frame was my data set. Now remember, it is a data frame. It is not a 2D list. It was the thing that was converted from 2D list in the previous example. Okay. If you're going to try to do this with a 2D list, the problem is the column names are not automatically known, and Jupyter may have trouble pandas may have trouble figuring them out. So just use the data frame. The column names are automatically associated and you get them. So anyway, aesthetic, a plot object from data frame with an aesthetic. Now I could say X equals year, but you don't have to. By default, the first value is year. I could say Y equals candidate votes. I don't have to. I could just say candidate votes on the Y-axis. And now a geometry, I want a column. There's not much difference between a column and a bar chart. A column chart has more freedom than a bar chart. A bar chart's very restrictive. So as you get into this, you're going to find you like a column a whole lot better in most cases. So when I run this, this is the plot that I get. This is a bar chart. Now remember, this is adding the votes together in each year for every Republican candidate, whether they won or lost, no matter what state. So for example, in 76, the Republican candidates totaled about 62.5. So ballpark 60 million votes, whereas in 78, they only got about 27 million votes. And it may be interesting to go back and figure out historically why that was the case. Yeah. In some cases, remember, not every U.S. Senate office is up for election every 2 years. Only a third of them are. Maybe that year There were simply not many elections in big states, maybe not California, not New York, Texas, whatever. Or maybe there were just elections in states where Republicans got crushed. Maybe if you did this for Democrats instead, right, you would get a different one. Okay. And so this is what a column chart will look like. Make sure you have the proper things imported. ggplot, data frame, from data frame, that's my data set, with the aesthetic, X equals year, Y is candidate votes, and I want to do column. Now, by default, you get black and white. If you want it to be a little bit fancier, the only thing I did here is I added in the color, and the color was a year. I called it the factor of year. Plot9 automatically gives me a color code that tells you what they mean. It just means each year is a slightly different color. And when you color it, you can start to see, this is actually here in the black and white, but you can't see it. Each of these little sections is going to be a different state. So you can go through and you can see how many votes in each state the particular Republican candidate got that added up to this total. The totals here and the totals here are going to be the same. But with the addition of color, you can now see the divisions, you can see the marks, and these marks divided up into each specific state. And so you could blow this up and you could start seeing that, oh, here was a state where the Republican candidate, whoever it is, got a whole lot of votes. You know, in Delaware, there simply aren't that many votes. So the Republican probably didn't get very many because for a long time he was running against Joe Biden, et cetera, et cetera. Whereas in Texas, you know, he probably got a lot. In California, he might have gotten a lot and lost anyway, and so on. So you get more data by adding color. Now, let's see if I can manage to do this without messing it up. If you said, I just want year, color by year, not factor, and hopefully this will not run, it doesn't break it out as fine granularity. Play around with this. I've pointed you at the user manual. Play around and see. The basic graphic is different, but the scale is a little bit different. It doesn't give you as much information. That was the difference between saying year is a factor versus year is just the variable. So this is a column chart that you get when you run this. Okay. So now here, as I said, I created a data set that was just Republicans. I called it Republicans. Here is something I wanted to point out because I've had questions last semester and this semester. It doesn't matter whether you put this aesthetic in the ggplot object here or whether you put the aesthetic in the geometry column. This is just to illustrate this is essentially the same as this. The only difference is here at the time that in this example, the data frame and Republicans were actually the same data. Here, I put the aesthetic in the ggplot object. Here, I put it in the geometric column. It doesn't matter. Okay, for the work we're going to do, it doesn't matter. You can put this aesthetic either place. You can put it in the geom col. You can put it in the ggplot. It will not impact your grade, and it should not impact how the drawing looks. Okay, so this is our data. Now, when I wanted to look at 12, section 12, I think it is, where I looked at Maryland, Virginia, and Pennsylvania only. I created a data set called MVP. MVP has all the values that are Maryland, Pennsylvania, and Virginia by themselves, and that gave me this data frame. So now I'm going to play around a little, and I'm going to warn you, this is, yes, intentionally an ugly chart. When you start playing around with it, one of the things you're going to do is you're going to have to see how you can make Section 12's chart for Maryland, Virginia, and Pennsylvania less ugly, and I'll warn you it's going to be hard. I think right here I've still got a column chart. I think I told you I wanted you to use a line chart. So let's look what a line chart where Pennsylvania, Maryland, and Virginia are. In this case, my data set is I called new MVP for Maryland, Virginia, Pennsylvania. So that was a column chart was playing around with, was seeing if it could be more legible. The instructions say use a line chart. So let's draw a line chart. Okay. That stinks. Okay. That is almost impossible to get any value out of. Well, fill is not a line chart command. So it essentially gets ignored. So let's change that and say, well, color. Let's run it again with color instead of fill. Does that make it any better? In my opinion, not so much, right? It tells me that all these kind of brownish lines are the results in Maryland. All the greenish lines are the results in Pennsylvania. All the purplish lines are results in Virginia. Now, what Plot 9 is trying to do here is it plotted the points of how many votes the candidate got for each party. Because remember, in this case, I'm dealing with both parties, and I want to group by party. I want to put the Republicans together, and I want to put the Democrats together in case there were more than one. And this is what I got. And Plot 9 tries to draw lines between, this is Pennsylvania, and let's pick a decent year. This is 2016. In 2016, the Republican Senator Pat Toomey from Pennsylvania was running. He won. He got a whole lot of votes. This is, I think, 3 million. Yeah, he got almost 3 million votes. 6 years earlier, whoever was a Republican candidate in Pennsylvania got a lot of votes, and so on. I've got Democrat votes in here too. So you got these things bouncing all over the place. In 2010, somebody didn't have an election. Okay, the 2020 results aren't out yet, so I couldn't have you do 2020. But as you know, there was no U.S. Senate election in Maryland in 2020, so that's why you get votes with 0. And so this, like I said, it gets ugly. Just for kicks, let's take group party out of it, and see what we get instead. Okay. Well, it makes it a little better, right? Because I'm not trying to connect lines of Republican here and Democrat here. I've just got things. It's still not very useful. You can see that the number of votes for a Democrat for a candidate in Pennsylvania go all over the place. For one in Virginia, go all over the place. For one in Maryland, go over the place. And you look into this and see how it goes. So what I want you to do in section 12, okay, I've given you the basic. For section 11, you're going to get decent charts. For section 11, you're going to get something that looks sort of kind of like this. This is probably good enough. You get the point across. In section 11, with this column chart, you get the point across. This is a research report you're turning in, and you could draw some conclusions, and you got to report your conclusions in Markdown. And you have to have Markdown cells when you report this thing. In section 12, you're going to have to look around. I'll warn you up front, there's not a lot you can do. Don't spend too much time trying to make it pretty. But the bottom line is you're going to wind up with something that looks like this. But I do want you to play around with it a little bit and see what you get by changing some of the parameters. Okay. What if instead of coloring by state, what if I colored it by party? Okay. Well, now I've only got Republicans and Democrats, and I can see that, but the problem is I'm lost, the different states. I've lost the Maryland, Virginia, Pennsylvania part of it. So that gives me some interesting data, but not as much as I want. So what I want you to do is play around with this, and this is why I'm giving you, for those who joined late, I have extended the deadline. This assignment is no longer due Friday. This assignment is due next Monday, the 7th at midnight. So after the next lecture. So you have the weekend and next lecture to do this. But that's what I want you to do. And then section 13 is to be creative. I'm not expecting you to draw a map. I would be totally blown away if you did, but I'm not expecting you to do that. But what I want you to do is play around some more and use this grammar of graphics to do some interesting things to say, oh, look, I learned this about the data. I learned about vote trends. I learned that, there doesn't appear to be a strong trend in the number of Republican votes over elections because sometimes they're up, sometimes they're down, and there's a lot of different factors. And so there doesn't appear to be a strong trend. If there was a strong trend either way, you might be able to tell me, oh, the party's growing, the party's weakening. Okay. This is what I want you to do, though. This is the whole point of Project 3 for this class, as opposed to what the majors are doing, is you're doing the Python programming, and there certainly, as you've seen, enough Python programming here, and I even left the sort stuff out that you got to do. But the Python programming is not the be-all and end-all. The Python programming is simply a matter of putting yourself in a position to do some analysis, to report results, to deliver your research. And that, as unless you are going to major, that's going to be the key thing. You're going to want to be able to take your comp sci and use it to do meaningful stuff that you can report back. And that's all the time we have. I did say, just real quick, I said, you can't do it, but how much easier Pandas is to do these data frame things. So I had my original data frame that I got from reading in the data. It's called data frame. So now what I can do with Pandas, again, you can't do this, is I will define states equal the list of Maryland, Virginia, and Pennsylvania. And then I say new DF. I want all the elements from data frame where the header is called state PO. Dot is in the list states. That's all it takes to get me just the Maryland, Virginia, and Pennsylvania ones, and to get you the Republicans and Democrats, I say parties equal the list Republican, Democrat, and now final DF equals new DF, the elements from new DF where sub party dot is in parties. And by running those two commands, except for Bernie Sanders and Angus King, I throw away everything. And with just this, that's how I got to this down here. And so, for example, this, that you can see the code is right here. It's where I did it. It's just that simple little code. How I got the columns, it's just there. It's just straightforward. But like I said, if I let you do that, there's simply not enough Python coding. That's why you have to solve it the old way. But there is, once you get going, all this easy stuff to do. That does exist. I acknowledge it. But again, you're not allowed to use it this time. You are allowed to use the commands to change from data frame to 2D list. And when you are finished building the proper 2D list, you are allowed to use the command to change it back to a data frame, because ggplot is a whole lot easier to use when it's a data frame. It's a whole lot easier to use when it's a data frame. So you are allowed to use that command at the end to change it back into a data frame and run this sucker. Okay, but I want you to actually do the Python coding to select just the Republicans, just the Democrats, just Maryland, Virginia, Pennsylvania. So, and with that, I will see you next Monday. Good luck. Have a good weekend. I'll let the TAs and everybody know that I've granted this extension because I just decided on that right before the class. And have fun.